Hey folks, so this is section 4.5. I'm going to break this section up into several different videos, probably 5 videos, so just be aware of that. You will have several of them to watch. Section 4.5 is all about integration by substitution. Let's look at the tip list first. It's fairly lengthy, but I'll go through it with you as we go through the first few questions. So the first thing that you want to do is you want to choose a u for your substitution, and usually what you're going to do is choose the inside. You'll see what I mean there in a minute. Secondly, you're going to find the derivative of u with respect to x. You'll want to move the dx to the other side. And sometimes you're going to have to manipulate either du or dx if possible. Thirdly, you want to rewrite your integral. And instead of using x's and dx's, you're going to be using u's and du's, and you're going to do that by substitution. Your goal here is that you want to get rid of all x's, all dx's, and you want to replace with nothing but u's and du's. Then you'll find the integral with those u's. Once you find the integral, go back and get u back out of there. We want to go back to the original x because that was what we had to begin with. So you want to go back to the original x's, and then if it's a definite integral, you want to evaluate. All right, so let's just jump right on into the first example here. You'll notice that we have an integral, and there is no such thing as the product rule for our integrals, so we have to do something that we haven't been able to do before. So like I said, for step number 1, we want to choose a value of u, and that's usually going to be on the inside. So I'm going to choose my u to be x squared minus 9. Step number 2, find the derivative of that. So the derivative is 2x. Step number, well, not step number 3, but the bullet point under step number 2 says we should move that dx to the other side. So we're just going to multiply on both sides by dx so that we have du equals 2x times dx. Then for step number 3, we're going to take our same integral and we're going to use u's and du's. So what we're going to do here is this guy is going to get replaced with a u. So we're going to have a u to the third power. And then the 2x dx, all of that, which is down here, is going to get replaced with a du. So now I have my integral written in nothing but u's and du's, and I'm going to integrate, and then we'll go backwards. So first of all, integrating, that's going to give us a 1/4 u to the 4th. Don't forget your plus c, because this is an indefinite integral. But I don't want this as a final answer because u's are not in my original integral. So I want to go back and replace what u equals. And so we're going to put that u out of there, substitute it with what it equals with the x's. So x squared minus 9 is replacing our u. Don't forget your plus c. And that is our indefinite integral. All right, let's go down to the next example. So once again, let u be what's on the inside. So that's going to be a 3 minus 4x squared. And so automatically then I know that this piece is going to be a u. So I'm going to go ahead over to where I'm starting to substitute, and I'm going to have a u raised to the 1/3 power, rewriting the cubed root as a 1/3 power. All right, so let's come back over to the left side then, get the derivative. So the derivative is going to be a negative 8x. I want u's on one side and x's on the other side, so that's why I'm multiplying on both sides by dx. So now you can see that this is the piece that is still sitting there. This is the piece that I haven't replaced yet, and all of that can be replaced with a du. So then we'll integrate. Don't forget your plus c. And then you want to resubstitute back in with your x's, and again, don't forget your plus constant. All right, going on to number 14. So the inside is going to be your u. That's going to be 6 minus x cubed. Take the derivative, so that's going to be your negative 3x squared. Get your dx to the other side. All right, so now let's start our substitution. So I know that this piece is going to get replaced with a u. So I'm going to have a u to the 5th. The only thing that's left then is the x squared and the dx. Unfortunately, though, that's not what this says. So I want to keep the x squared dx part, but that negative 3 part, I want to move it over to the left side of that particular statement. And so I'm going to have a negative 1/3 du equals x squared dx. So that now my x squared dx can be replaced with a negative 1/3 du. And remember that with a constant multiplier, you can always throw that out to the front. And so that's what I did with the negative 1/3. All right, so I have the negative 1/3. The integral of u to the 5th is going to be 1/6 u to the 6th. Don't forget your plus constant. And then I'm going to do two things at once here. I'm going to multiply my fractions out in the front, but I'm also going to take my u and resubstitute back in my x's. So I have a negative 1/18 times a 6 minus x cubed. All of that quantity is raised to the 6th power plus my c. All right, looking at number 22 then. The inside is down on the bottom. So that'll be a 1 plus x to the 4th. When I go and write this down, I'm not going to write u squared. I'm going to go ahead and move that to the top and write a u to the negative 2nd power in a minute. All right, come back over to the left. Let's go ahead and get our derivative of u with respect to x. So that's going to be 4x cubed. Get dx to the other side so that there's one side with u's and one side with x's. Now, once again, when I'm going to get ready to sub in, the only thing I don't have something subbed in for is x cubed dx. So I only want this piece on one side alone. That 4 needs to be shifted over to the left side. So it's going to be 1/4 du equals x cubed dx. So I've already substituted in my u. Let's go ahead and substitute in for our x cubed and our dx, and we're going to replace those with a 1/4 and a du. Here's where I actually, sorry about this, went and put my u on the top, made it with a negative power. Once I integrate then, u to the negative 2nd power is going to be a negative 1 u to the negative 1st. And now that I've integrated, go ahead and add your constant. And then we're going to clean this up, but not only are we going to clean it up, we're going to also resubstitute back in with our x's. And I just went ahead and moved the one that had a negative power to the bottom. All right, number 26. So the inside is going to be what's down on the bottom underneath the square root. The derivative of that is going to be 4x cubed. Multiply by dx on both sides. And once again, as I'm thinking about substituting, this I can substitute with a 1/2 power on bottom or a negative 1/2 power on the top. So let's go ahead and unhide that over in our integral. Okay, so u to the 1/2 power. But then I still have an x cubed and a dx that's sitting there that needs to be substituted. But as you can tell, I have more than that. I only want the x cubed dx alone, so let's get the 4 to the other side, much like we did in the last question. So then for x cubed dx, I'm going to replace that with a 1/4 and a du. We can go ahead and get that u up to the top with a negative power, and then we'll integrate. So the integral of u to the negative 1/2 is 2u to the positive 1/2. And then I'll go ahead and resubstitute in my x's. And once again, don't forget your constant. For the next example, before I do anything, this is already in two terms, so I can look at these separately. But that second term is the same thing as 1/9x to the 2nd power. And so I'm going to leave the 1/9 alone, but the x squared I'm going to move to the top to make it an x to the negative 2nd power. There's actually no substituting to do in this particular question. This way, the way I'm doing it is just fine. So the integral of the x squared piece is going to be 1/3 x cubed. And then the integral of the 1/9 x to the negative 2nd piece is going to be a negative 1/9 x to the negative 1st. Don't forget your constant. And then at this point, I really didn't do a whole lot of work other than clean up what was already there. All right, and then this one would be the last one for this particular video. So the inside of this is going to be our 5x squared. So that takes care of subbing in for this guy. But I still have an x dx that I need to take care of. So let's go ahead and get our derivative. Derivative of 5x squared is 10x. Let's get our u's on one side, our x's on the other side. That 10 is in the way though, because all I want by itself is the x dx. So move the 10 to the other side. And now I have everything I need. So using this piece first, let's go ahead and substitute. And that's going to be a u to the negative 1/3 power. Moving it to the top there. And then the second piece, that x dx part, let's replace that with the 1/10 du. Again, constant multiplier can always be rewritten out front. So I have my 1/10. The integral of u to the negative third is going to be 3/2 u to the 2/3. Add your constant, and then resubstitute in your x's for that. The only thing that you could do is to rewrite this as a cubed root, but that's not entirely necessary, so we'll just leave it as is at this point.